Okay, yeah. Good morning. I'm Ujin Lee, Solution Architect at AWS. I'm delighted to welcome you all to my session today, and I'm honored to be present alongside two special speakers from Samsung Electronics, Changyi Park and Youngkyu Hwang, who will be share their journey of running a complex design environment on AWS. Before starting the session, I'd like to emphasize that they are not IT professionals, but fabrication construction manager and engineer. So what makes their perspective unique is that they have built and are operating design platform by themselves from end-user standpoint. So I hope that through this session, you will gain the insight that can help address the challenge you are facing if you are considering how to accelerate your design work. In this session, I will begin by defining what a design platform is and introduce how to build your own platform on AWS. Then we will share Samsung Electronics DS journey in building a design platform. We will explore the challenges Samsung faced, solution, and outcome Samsung achieved. Finally, I conclude the session by summarizing key points we've covered. Okay, let's dive into our session. I'd like to begin by defining design, particularly industrial design. This is a highly specialized field that aim to create optimal design for user and your business. It includes everything from small devices we use, electronic components, automobiles, and even buildings and specialized plants like a fab. Normally, the process of creating these design outcomes involves large groups and complex data sharing. To proceed the design work, it's essential to have an environment where many designers can collaborate effectively. However, this environment comes with three main challenges: productivity, security, and management. Typically, multiple groups or even different companies exchange data while working on designs. To enhance the productivity, our designers prefer to work in an environment that's familiar with what they used and accustomed to. Moreover, it's common for work to be carried out from various locations, not just a single site. Another major concern is security. The design data necessitating extremely high level of security regulation. It is required to manage not only data leak prevention, but also control user access. Such a scenario significantly increases the workload for IT personnel. They will be required to manage a complex network and large-scale infrastructure resources to support them. To maintain a security in an environment where user access from the distributed location, we can consider a centralized space. This centralized space also allows us to maintain a data consistency throughout the end-to-end design flow. However, we still face several challenges from user experience, performance, such as latency during remote access, and ensuring the availability of essential design tools. By integrating a centralized space with various elements, we can create a design platform to address the challenges we discussed earlier. We can modularize each required features as shown in this diagram. Designers start from the device at the top layer and are registering and authenticated to use the platform. They then access the platform with high performance stream protocol, then do their work through their VDIs. Only through the VDI, they can access the data and perform a design work according to their assigned permissions. I'd like to draw your attention to the areas they highlighted in yellow boxes. The tool required by designers in different groups can vary. This means that while administrators provide a common design tool, they must also offer a flexible VDIs that allow users to install specific tools they need. This is related to productivity. Moreover, to manage large-scale platform and accommodate diverse VDIs environment for each user, we inevitably consider automation. To apply automation and provide user convenience, we introduce user portal and management portal. Administrators can also effectively manage the whole platform, infrastructure, and user access through management portal. AWS offers a comprehensive suite of services for building your own platform. While I want to go into the specifics of each services in this session, I'd like to highlight some key offerings. AWS provides a full range of services from network to collaboration tools. You can store data in a cost-efficient way and accelerate your design work with the latest GPU instance. Beyond the infrastructure, AWS also offers virtualization and orchestration to manage VDI and your users. Also, you can communicate securely only within the platform with your designers. Most of these services are managed services, so you can easily and quickly build your platform according to your business requirement. With these comprehensive AWS services, you can build the platform that doesn't compromise on productivity, reinforce security, and utilize managed service to support large-scale infrastructure. This powerful combination enables us to meet the complex demand of modern design flow. Now, let's take a look at the high-level architecture of a design platform, which is composed with various services mentioned earlier. The architecture is structured into 4 main layers and isolate each VPCs. Let me start at the bottom. We have a data VPC. This layer is crucial as it's where all design data is stored in a cost-efficient way and only allowed to the access to the data with VDI within the computing and DCV VPCs. Designers can connect the VDI with a private network, and before connecting the VDI, the directory service authenticates the user and verify their permissions. This ensures that only authorized personnel can access the specific data. At the top of the architecture, we have an inner gateway for connecting external partner solutions like chat, email, and other design tools. To protect our whole platform from external threats, we can place some kind of security system like a firewall. The multi-layered approach ensures we maintain a balance between accessibility, functionality, and security. How about the performance? When building a design platform, one of the biggest concerns is user experience and performance. I'd like more emphasize the Amazon DCV, which is enable design work from a remote environment. Design work, in particular, demand higher resolution quality, and designers are sensitive to the response time of every mouse movement and click. Amazon DCV address these critical needs of designers, also provide security and various features necessary for enterprise-grade deployment, like logging, controlling data transfer, and integrate with other systems like directory, service, and single sign-on. I will prepare a brief demonstration to show actual streaming performance of Amazon DCV. For this demo, I will set up a comparison between RDP and DCV to each instance on Oregon region. Approximately 9,000 kilometers away from my laptop in Korea, and I use accelerating computing instance with L4 GPU. As you see on the screen, there are some noticeable differences. First, we can observe the difference in resolution quality. More importantly, we can see some slightly delay in streaming with the RDP protocol. I want to clarify that this doesn't mean RDP is a poor protocol. In fact, it is widely used for remote desktop connection in many scenarios. This demo aims to illustrate that for streaming 3D content and high-resolution graphic, Amazon DCV is more suitable. Through this platform based on Amazon DCV, we can accomplish a wide range of tasks, include digital content creation, engineering simulation just with C, the 3D applications such as CAD, and even though semiconductor design. From now, I'd like to turn your attention to a real-world implementation of the design platform. Please join me in giving a warm welcome to our speakers, Chang-hee Park and Young-kyu Hwang.
Thank you, Jim, for the introduction. And I will be presenting the journey of how Samsung Electronics built a design platform on AWS. My name is Young-kyu Hwang, and I'm senior engineer who worked as BIM manager on this project. And joining me is my co-presenter Chang-hee Park, principal engineer who served as project leader. There were a few more collaborators on the Samsung team: Taekyun Kim, Sang-min Park, Keun-hyuk Ko, and Junyoung Lee. They cannot join today's session. They made significant contributions to develop and test the platform, bring it to its current state. Briefly introduce our company, Samsung Electronics. The DS division, also known as Samsung Semiconductor, is a global business unit that produces semiconductor chips for various electronic devices, including smartphone, home appliances, and data center server. The picture on the left side, our Pyeongtaek campus in Korea, which is home to the headquarters of Samsung Semiconductor. This factory, known as PAPS, produces memory chips such as SSD and DRAM, as well as non-memory chip, AP, and CPUs, serving customers worldwide. We have been built PAPs in many countries and have been a major supplier in the semiconductor industry since 1983. According to report 2024 Q1, Samsung Semiconductor was responsible 11% of global semiconductor production. However, The design and construction of fabs are among the most complex type of large-scale construction project. Iconic structures like Burj Khalifa in Dubai and irregularly shaped buildings like Dongdaemun Design Plaza in Seoul are known for being very difficult to design and build. Only a small number of architectural and construction companies have the skills to complete such projects. In the same way, fabs are very complex to design and build because of many challenging factors. Designing and building fabs is not only very complex, but their size and performance needs have also changed as chip technology has improved. In 1983, chips were made using 2100 nanometer technology. By 2020, this has advanced to 3 nanometer technology. As more advanced technology is used for making chips, the requirements for the buildings that support this process have become much stricter. This has made it necessary to use more advanced design methods for fab construction. The design and construction of fabs are not only complex, but doing them on a fast-track schedule in a high-security environment has created many challenges. In terms of security, fabs operate at a national security level. For the schedule, the process does not follow the typical design build method. Instead, frequent changes are needed whenever new chip technology is developed. Samsung has traditionally used an on-premise IT system to manage design and construction. However, data silos between different stakeholders often occurred, leading to costly issues during the construction process. To solve this problem, a new approach was introduced using AWS cloud technology with a data lake concept. Regarding this, our project leader, Chang-hee Park, will explain the technical detail using AWS cloud.
Thank you, Youngju, for the introduction. Hello, my name is Chang-hee Park. I'm working as a principal engineer at Samsung Electronics and working as a project lead of this project. So as Youngju mentioned that we have some limitation of our on-premise system. So that's why we have initiated for using the cloud environment to overcome the limitation of the on-premise environment. And for overcoming that stages, we're going to presenting how the journey of the development of our design platform. So at the initial stage of the concept, we define the requirement of the design platform. So as shown in the left figure, we firstly conceptually define the requirement. So first requirement, we should integrate the data management. As you show that the data silo is not good for the cooperative environment. And second, network reliability is needed because we're going to using the cloud environment. And the third, and the security management, because we handle the very important drawing, so that's why security management is important. And number 4 is that easy accessibility for the cloud is needed. As we already mentioned, anywhere we should approach to the platform. So for implementation of this requirement, we consider and evaluate so many vendor technology for the implementation and direction. As shown in the right figure, for the integration of the data, we're thinking about the SaaS solution. As you might heard about, there is a solution like Autodesk. They are selling the public SaaS solution for the drawing. But that's the public SaaS, so that's why we want to making a secure platform. So we're gonna select the Autodesk, but we're gonna start the customizing to reserve the SaaS solution using an unsecure environment. And for the second, for the network reliability, because we are handling very big data, something like 3D drawing, so very high workload was demanded. So that's why for the network reliability, we are providing the private network line for the designer and the construction firm. And also the VPN concept was utilized. And the number third, for the security management, we are using the integrated on-premise AD. Because user information is so important, because we need to identify the exact user, exact access, and what they are doing in the platform. So that's why we are using our on-premise AD for the design platform. And for the easy accessibility, we are accepting the AWS technology. So automated, easy to provisioning with Amazon DCP technology was adopted. So this figure shows the initial prototyping of the architecture of the design platform. As shown in the left figure, this shows the local environment. So all the PC located in their firm, and then local beam server connecting to the PC, and then they are isolated from the internet. So the local beam server not giving us utilization of the drawing, and the data is very limited. So for resolving that issue, we designed the secure cloud architecture as shown in the right figure. So as you see here, the local client accessing to the graphic VDI first. So we are using Amazon VDI, and then those VDI connecting to the Amazon file server, which is FXX. And those FXX was a pipeline with the Autodesk server. So data go to the Autodesk server like every day, so that they are translating the data on the web version so that the data can be utilized instantly. So by doing this, we can making a high utilization of the drawing, and data expected for all the users is a way better environment compared to the local environment. So from this slide, let me show the platform journey per stage basis. So let's say from the POC stages and architecting and prototyping the platform and the optimized stages. So in the POC stages, we are emulate the user experience and performance for complex CAD application. As you might heard about, they are using a workstation, right? So workstation is a very resource intensive. So that's why making the emulated experience to the cloud environment was not easy. And the architect and the platform stages, we are keep checking that our platform is way good for the user, for the meeting the security, and also the high performance for the user experience. So we are keep iterating our prototyping and then verifying that whether they meet those requirements. And then after we verified, we are optimizing the operation. So there was some manual process, but we are finally provide our system with a self-service. So all the user should use the self-service. So all the process automated, and the resource also should be optimized for the cost reduction. And also the network stability, that kind of all the operation was the customized, optimized in the operating stages. So let's look at a little bit deeper look at the POC stages. So in the POC stages, designer's experience was very important. So designer's experience is actually not documented well. So let's say they are using some application and the mouse panning, or something like keyboard key down and up, and also some kind of execution time or the data transferring. That kind of user experience well documented in the POC stages. That was using for the criteria, for the performance criteria in the VDI. So after we estimate the local criteria, then we check the VDI performance. So the main criteria was that design performance and their response time is comparable to the local environment was the key. And then the security feature. So as we mentioned, the corporate compliance keep us meet the requirement. So we are keep see the security feature is meet our corporate security. And this is the architecting stages, so prototyping the platform. As you see on the right side, so we starting making the VPC in the cloud zone. So we set all the graphic VDI on the bottom, right? And on the bottom, all the VDI located. And then on top, we put the VPC zone with the admin and the management. So admin and the management zone, there is a file server, and there is another something like a license server, and which really required for the admin of this VPC. And on top of that, we put another security layer. So that's a security, something like a firewall. Firewall, also some like a SIM VPC can control the ingress into the internet faces. They control the firewall and all the platform making it secure. So this right figure was our platform prototyping architecture, and then left side, the user access. So user using direct connect for the connecting to our platform, or at the left figure show, they are using the VPN as well. So we finishing the prototyping, and then we verify that this quite a proof that the performance is meet our requirement. Then we starting the optimizing of our platform. So as you see here, we make one custom portal. So those custom portal, user not directly go to the custom portal first, and then they authenticate their identity, and then they choose their design environment, and then after they submit and then get the approval, their information is correct, then automatic VDI provisioned by the custom portal. So the custom portal in the backend side, all the deployment of the EC2 was deployed well, and then they are accessing to the design platform and directly. During this process, they are not only provided for the EC2, their network configuration, such as like FXX configuration, already built in those backend system. So they are taken directly connecting to design platform, as shown in the number 3. So this is the automation process so that they can self-service for all the procedure. And as you see on the number 4, we also build another admin portal. So the admin portal mainly work is that they control the resources and the user management. We're going to show you later. And the number 5, because we need to operate this system on limited budget, so we are also custom management in the admin portal. So this slide shows that the final architecture of our design platform. As you see here, on the bottom, and the right side on the bottom, the graphic VDI, and on top, there is the admin VPC, and then on-premise SaaS, like custom portal. And on top, there is a security layer, so firewall and the SIM server, like a Splunk, was located. And then they are facing the internet, but with their policy control, they can limit their access only designated SaaS solution like Okta and Autodesk. So this is our final, the architecture of the design. And all the vendor in the left side, like even their designer or ourselves as a client, and also the construction firm, are directly connecting to the cloud using their direct access or the VPN. So with equipping all this platform, we finally deploy our system in 2024 and operate to pursue both design innovation and security robustness of the Samsung Pack construction on AWS infrastructure. So from this slide, let me show you that a few image to show the key feature of the design platform. As you see on the left figure, this is the DCB client images. So people accessing the platform using this terminal. So they put their information, and then they entering it. Then they can see inside of the platform, as shown in the right figure, they can see the design, and also not only for the design, they get the software, and then all the configuration was already pre-packaged, and then they can instantly start the design review. The most important part in here is that we are using the remote design concept. So that's why, as I mentioned, they are using the workstation concept in the before, but this design concept can be implemented if their local device resource is not good, such as like just general PC. They can have almost similar experience like a workstation in this environment. So let me show a little bit more for the feature of this design platform. So number one, so we are integrate our on-premise Active Directory on the platform. So once user join the Samsung AD, the user information synchronized on the cloud platform. So consistent user information is provided for the application layer, such as in SaaS. So in other words, because we are connecting our on-premise AD and the platform, and we are adopting another IDP solution like Okta for the SaaS synchronizing. So we can using all the information constantly, not only for IaaS system and the SaaS system. By doing this, we can synchronize and also automate user provisioning, not only for the IaaS system, but also the SaaS system. So as you see here on the right side, if we adding some user in the project in the Samsung AD system, then they are also get license for the Autodesk license as well. So number two, so that's why, as I mentioned, automatic provisioning of the graphic VDI and SaaS account was enabled. So graphic VDI per AMI template image, which means that all the image package was installed and stored in the AMI image, then those AMI image provided by self-service was custom portal system. I will gonna show you a demo. And also SaaS accounts are automatically provisioned via user sync between the IDP vendor such as Okta and Autodesk provider. So this is demo. So user, when accessing this custom portal, they don't have the VM, right? So no VM are available now, and then they can apply the new VDI application. Then they write the information and then describe the reason, and then as I mentioned, on the right at the bottom, they select their VDI template. Because we know their AD information, they have the selected VDI image, and then they select it, and then they request the approval of their request. So after that, in the backend side, the cloud system provisioning for the EC2, and then after provisioning, the left side images was changed with their IP address, and then they are pushing the right button in the blue button, then they are connecting to the their VDI in the DCB client. So like this one, they accessing to DCB, then as you see in the right side, they can, because they are using the AI image, so they're all the pre-package of the software like AutoCAD and the Revit or Navisworks, that drawing was pre-packaged. And also, because SaaS was also provided, they can start the review as well. So this is the whole concept of the design platform and the demo. And number three, this is a new concept. So we, using the SaaS solution, we can achieving that web-based drawing and data model. So this is very different for the local environment, because the SaaS solution translating this design data to in the web format, then we can using this data from not only from the just a local file, we can using this data is other format. So such as like we can store those data into the database, and also we can extracting like the CSV. So by doing this, we can connecting this data to the other module, such as construction scheduling or construction estimation. And also in the future stages, the AI model also can learn this data so that if this data input for the AI model, they can interpret, and then we can also provide some innovative service such as chatbot, so we can interpret this drawing with the natural language. And number 4 picture is quite a typical. So we managing overall design platform like this admin portal. So we can see, as you see, all the number of the users and VDI and the project in the design platform. And number 5, this is the last picture. We apply the security monitoring via SIEM. So all the user information are collected, and then their information also analyzed in the SIEM server. SIEM is a security information event management server, and then if there is a suspicious account activity it is reported, then we can disallow them for the design platform. Okay, this is the end of my journey of the design platform. And the benefit of the design platform using the AWS was 3. For me, first of all, the handling graphic heavy workload was enabled. So as I mentioned, our workload is quite big, but using the G4DN EC2 and the DCB client, they are very optimized for the handling of the heavy graphic workload. And second, managing platform infrastructure by API. So they provide API granularity, so that enable full and autonomous control of the platform. And number 3 is that security control. So dedicated security control option ensure the security robustness. Even we put our design drawing in the cloud, we can get cooperate compliance. The next page of the fab design platform will be continuous develop on the AWS infra. So we're gonna keep optimize our performance. As you might heard about, like there are another instance such as G6 license, which is faster than G4 license. So we're gonna keep optimizing the performance. So our dream is that our platform is way faster than even the local environment. And second, we're gonna apply the AI and the ML integration. As we mentioned, like those data is a huge data. So handling those data is quite cumbersome for the human. But if we integrate this algorithm, we can easily interpret it, and then we can giving more information to the stakeholder. They have an appropriate decision in the right timing. And the final, we're gonna keep cost optimization. Cloud environment platform is not cheap. So, but the workstation is not cheap as well. But we want to hope that the cloud cost is quite cost effective, so that many users can accessing and using our platform in the future. This is the end of my presentation. Thank you.
Okay, thank you, Chang and Youngyu, for fascinating journey of Samsung DS design platform on AWS. Okay, as we've seen, it was far from a simple task. There are significant challenges to overcome, such as strong security and providing high quality of user experience applying automation. However, despite these complexities, building a design platform using cloud technology was essential for innovating current design flow in fab construction. Lastly, AWS offers a wide range of solutions for both the user and operator, and is helping you building your own platform to accelerate your design process. I hope this session has helped you to address the challenge and improve your design work. Thank you so much for your attention, and I look forward to seeing everyone again at another future session.